developer advocate on the containers team here at AWS. And as you can see, that's my Twitter handle below. And next to me is Brent Langston. I'll let him introduce himself.
Hey, I'm Brent Langston. I'm also a developer advocate on the container services team at AWS. And that's my Twitter handle as well.
Cool. So Brent's definitely funnier and more exciting on Twitter than I am. So I strive to get to that level, maybe one day. Um, so
Thanks.
uh, so today what we're going to do is obviously we are on the, we work with the containers team. And so today what we're going to do is we're going to go through a workshop. It's called ECS Workshop. That will essentially take us through um, a series of understanding what containers are. We're going to talk specifically about ECS, which is the Elastic Container Service on AWS. And this workshop we're going to span this out throughout the week. So this will go through Friday, and we'll go in sections of the workshop throughout the week. So um, Brent is who I like to call the father of ECS Workshop. He put a lot of amazing work into this workshop to get it out there for our customers to use, get hands-on, and interact with ECS Workshop. So we're going to go ahead and get started, and we're going to just get going.
Cool. Sounds good.
Okay. So what you see here is ECS Workshop. So before we get into it, I want to just let you know that you can do this on your own. You could do it while we're streaming in real time. You can do this with us. Um, the recommendation is that you have a clean, fresh, brand new AWS account to work with, um, and that's just it'll make things easier. Um, when you start building, and then when you're done, you can just delete the account. Throw it out. Um, so let's get started. So in the workshop, what we're going to do is we're actually going to launch basically a 3-tier polyglot web application. So it's going to be a web front end that is going to serve 2 API backends. And those every single application within this setup, this environment, is going to be different languages. So the front end's Ruby on Rails. Backend is going to talk to a Crystal API as well as a Node.js API. And as you can see here on the front page, as we start to build the workshop, you'll actually see in real time this diagram that will show you where your container is when you're calling that through the web. And you'll see what you're talking to, what availability zone it is, and what container it is. So as we go throughout the workshop, it's going to start with just the one front end. And as we deploy more services, we're going to see a fully functioning front end and back end service. So for today, we're going to primarily focus on an introduction to containers, to the Elastic Container Service, and we'll talk about ECS. So when I say ECS, just know that's Amazon's Elastic Container Service. That's the acronym for it. And we're going to talk a little bit about what that looks like, some of the definitions, just so as I mention some of these terms throughout the workshop, they're familiar and they're not strange. And then lastly, for today, what we're going to do is we're actually going to deploy the platform, which will be a cluster, a virtual private cloud, and all the necessary resources to get our containers ready to be up and running. So for the workshop, this is just a high-level overview of ECS. And as I talked about, we're going to just do, we'll talk about ECS, what it is, and the different components within the orchestrator. But first, I do think it's important to just kind of talk about containers and why containers in the first place. Generally, so I've been, I'm very fond of the DevOps world. I love to build things and automate infrastructure and build pipelines and build infrastructure in a way where developers can really focus on their applications and the business can focus on what matters to them, which is serving their customers. and getting, features out to their customers that matter, rather than focusing on back-end infrastructure and, you know, 1 week release windows and just, a lot of heavy lifting. So containers, in the old world, prior to containers, now containers have been around a long time, but they've really become prevalent just over the past few years. And previous to using containers, we used either, virtual machines or even bare metal servers. You spin up a server, you're going to deploy your applications to that server. Oftentimes, you may even have multiple applications running on that server. So there could be resources competing with one another. Different teams troubleshooting different things on one server becomes very tricky to manage. Deployments become challenging, as well as just simply if you need to spin up a new server, the time it takes to get that server up and running and operating as you expect. Uh,
Adam, sorry, I don't mean to
Please.
interrupt, but I used to work at Tumblr, and one of the things that we struggled with was trying to run multiple microservices on a single server. They always seem to have like different library requirements, different operating system requirements, different versions that they would depend on, and stuff like that. So um, one of the things that containers really helped with was being able to bundle together all the dependencies that you need in order to distribute your code plus its dependencies all as a single artifact. And I went back. It's really funny because one of the guys that I worked with, that was a long time ago that I was working there. One of the guys that I worked with, I still stay in touch with, and we were chatting. And I've been telling him about containers for a long time. He just texted me this morning, and he's like, "Dude, why have you not told me about Docker? This is crazy. This makes my life so easy." And he's like, just this morning started Dockerizing everything that he works with, and he's just like loving it. And it's because you can package together like everything that you need and just run containers on a server and move stuff around and have it be as dense as it needs to be. So like it's really awesome to be able to do that. And that's just one of the problems that containers solves. What's really weird though is just like with life, I'm sure when you solve one problem, you just open the door for the next problem. Um, so I'm sure in a week, maybe just in a few days, he's going to be like, so how do I manage all these containers? Because now I have a whole bunch of them. What do I do? So what do you suggest? Like, is that what we're going to be looking at today?
Yeah. First of all, great story. Thank you. And please interrupt me as often as possible. Um, that's such an awesome story. And yeah, so we're going to talk about that. But ultimately, the goal of this workshop is to go from, wow, containers are cool. Look at all the things I can do with containers. And then realizing now that I have this really cool container that has my application, all my dependencies packaged into one place. Now, how do I get that to run at production scale? And so I think that's what we're going to go through in this workshop. So that's a very good point uh, to mention. So, and by the way, that is, I think that's such a huge pain point of kind of the, managing virtual machines is different versions of your packages, and trying to manage that between multiple applications running on a server. It's super challenging. Whereas with containers, it's one application that does one very specific thing on that container that has all the dependencies it needs to run successfully on that container. It doesn't have all the dependencies of 10 other applications it needs. It's just very compact and does that one specific thing. So,
Exactly.
and so Brent, you kind of spoke to it, but really containers, allow developers, operations teams to iterate at a high velocity because it offers that speed of scale. You can, as you mentioned, you have that prepackaged container. You can run that locally. That is an artifact that will follow you from your local workstation. If you follow a Git workflow, once that change goes into Git and gets merged, it'll go through a pipeline. And then that same artifact you tested, with the exception, of course, of secrets and maybe some other host name variables that you would point to, it's going to be the same. So
Oh, 100%. I can't tell you how many times I had to go like track down a developer who had pushed some code, and I'd be like, I know this probably works on your laptop, but help me understand what I'm missing on the server because, it's not working. I launch, I get a stack trace, I launch, it just exits out. Like there's just all kinds of problems that I have to sit here and work through. And if I could look at how your laptop is set up and the stuff that you have installed, maybe I could more quickly figure out what I need on the server. And when you then transport yourself into a Docker environment, you list everything that's necessary in a Docker file, and then on top of that, you build and store an artifact that you can then take and run anywhere, and it'll run the same anywhere that Docker can run. This artifact, will be there and can execute for you.
yeah,
So having that ability, it alleviates so many problems of trying to figure out why is this environment not behaving the same way as that environment, and the implicit dependencies and all that stuff just they take care of themselves. It's really awesome.
yeah. It's so funny. Like when you mentioned that, I think that's the number one use case is developers working on something on their laptop. They have, let's say it's a Ruby environment. They're using the latest version of Ruby, but in production, you're running 10 versions back of Ruby. And, to be able to figure all these things out, it's so challenging. And it's just, there's more time spent on just trying to figure out who built things in what way in their isolated environments. Whereas containers, if a developer says, hey, this isn't working, okay, Docker pull, let's run the container, let's see what's happening in real time.
Totally. And when you go like before a Docker environment, what you have is a set of for to run a single application, a set of hundreds of requirements that have to be met. All kinds of stuff like I need to have these several hundred packages installed, and I need to have an interpreter like Ruby installed, and it needs to be a certain version, and so on and so forth. You go from that to a list that's like maybe 3 bullets long. I need to have the Linux kernel. I need to have the Docker daemon. Okay, maybe 2 bullets long. Like it's so awesome to just simplify it down that much, and then with that you can just run that artifact, and have it be the same whether it's development or QA or production. Like it's always going to be the same.
Yep. Yeah, I think my workflow is always just, test a new feature, it adds to my code, Docker build, add to my code, Docker build, Docker run. And we'll talk about Docker in a moment. If you're not familiar with Docker, let's actually just go straight there because I think we touched on what a container is. But high level, just Docker, it's a software platform that allows you to build, test, and deploy your applications um, as containers, essentially. So as we talked about, and I'm going to reference a quote from Brent actually, and that I love, and I use this when I talk about containers. So when you package a Docker container, it's packaged in what's called a Docker file, and I love this is Brent, you'll know right when I say it, but a Docker file is essentially a set of instructions, and it's the instructions that tell you, as you mentioned, what's my operating system that I want to run this on. Do I need to install any packages? Here's what I need to install. Where does my code live? And then after all that, simply what do I want this container to do at runtime? So that's basically it. It's a simplified way to build your containers in one file, and then a command line to get that image built. So a Docker image is basically your set of instructions built into an image, and then when you want to run a container, it runs from that image, just like an operating system has an image. The difference is in an ideal world, your container image should be relatively small. And just depending on the use case, of course, every use case is different. The Windows world is obviously a little different, but I mean, I've seen containers megabytes, just a few megabytes, maybe, 20, 30
Oh yeah.
megabytes. So, or
I
smaller.
think I think it's good if you're just starting out, just get a container to build and run, then go back later and figure out all the things that you need to tweak to really get it optimized and have it be, as small as possible and as efficient as possible. But don't worry yourself with that if today's your first day, if you're just getting started. Um, we'll show you some tips and tricks along the way to help you have a good understanding of what you need to be looking at later. But for now, let's just focus on let's get the container built, let's get the container to run, and we're that's more than half the battle.
Yep.
You mentioned the Docker file. One of the things that I love about the Docker file itself is just how simple it is, because they didn't. I mean, essentially, what Docker did. You said this earlier. Containers have been around for years. They've been around for decades, but that they've never been simple until Docker came along. And what Docker did is they built basically an interface around instantiating all of these different pieces of the Linux system into something that they call a container. And the way that you build the container, they kept that simple too. So there's not like this crazy API. There's not a difficult to understand language or format or anything like that. It's just a simple text file, and the first word of every single text file is a verb, and after that, it's the instructions that you want to pass. So, like, run yum update, run uh, rm-rf. Whatever it is that you want to do. What do you want to do? You want to run something. So here's the command that I want to run. It's that simple, and it's so trivially easy for anyone to understand that's been coming into this world from a systems world or a development world. They can get it like almost right away, and then you can sit there and build, exactly what you need, and then go back later and optimize it.
Yeah. Yeah. Man, it's just thinking of, configuring a whole, a server on its own and the difference between that, the contrast between configuring a virtual machine compared to configuring a Docker image. It's night and day. I mean, it's fun. They really made it easy.
Yeah,
And
totally.
I think, one last piece to speak to is whether it's Linux, Windows, you're running on a Mac OS, you can run containers. So. Um,
Totally.
all right, so let's talk about ECS. So, this is just the front page, our kind of front page description of ECS, but I do think it's nice to just run through. Basically, it's highly scalable, performant. It's a container orchestration service that supports Docker containers, and it supports them at scale. Basically, ECS eliminates the need for you to install and operate your own container orchestration software. And what that means is, now, if you're running, in a traditional, or I would say just outside of ECS, you have to think about the control plane. You have to think about these kind of leader nodes that are responsible for orchestrating not only where the containers are going, but orchestrating all the back-end virtual machines that are going to run your containers, making sure that everything's in sync and everything is communicating with one another. So when it comes to that control plane layer, ECS is fully managed. So that's something that is completely abstracted from you as the user of the service. Um, and if you go even a step further, which we'll talk about, is Fargate, where you don't even have to think about the backend EC2 virtual machines. You simply just run a container, and we'll handle spinning up the virtual machines, making sure that all that's set up and that your container can join your cluster. So it's
Yeah,
a lot of the heavy lifting is handled.
that's if I think about this in terms of my friend that I was just talking about. Today he's just starting out learning about Docker, and he's Dockerizing a lot of the applications he has to manage. Um, he hasn't, I don't think he's reached the point today, but I'm sure it'll happen this week where he's like, okay, now I can run all of my applications from inside containers, but how do I get them to launch across all of my hosts, And that's really what orchestration is about. It's the ability to have a higher level operator of logic that says this is where things should run, and it can make sure that stuff is running the way it needs to be. It can health check, and it can have stuff be placed where it needs to be, and if anything dies, it can automatically restart it. So there's all of this terrific logic that you just get by virtue of using ECS as your orchestrator. You don't have to write it yourself, and you don't have to have all of the test cases and checks that this thing does. It just comes with it.
Yeah. Yeah, and to add to that is just the native integration with the AWS ecosystem. So on top of it doing all these really great orchestration things, it just natively integrates with uh, the AWS services. So for example, auto scaling. You know, day one, you're going to get your container up and running. Great. Now your container's running in ECS, you've done it. Now day two is all of a sudden you have an influx in traffic and you need to scale that service. How do you do it? So this is where having those native integrations with CloudWatch, which is our metrics monitoring logging service, um, within ECS, you just basically are able to tie in your service, your task, your service to a CloudWatch metric and use that as your scaling. So common in the containers world is, it could be CPU, could be memory, but usually it's like queue depth, or network traffic. So if you see an influx in traffic on the load balancer, that may indicate that you need to scale your containers horizontally. And the best part is once you're done and you've served that traffic, you scale them back in. And that's all built into the auto scaling. So, and load balancing, there's so many, like I could just spend an hour and a half on this page alone because of all the native integrations. But one other integration I'll mention is with identity and access management. Gosh, it's been a while since we've had this feature. I don't know exactly when it was released, but basically with uh, ECS, you can have a task that runs, a container that runs that has permissions to access resources within AWS. You can attach an IAM role to that container. And let's say you had five different services running on the same EC2 instance. You could isolate and say only this service, so one out of the five containers, even though they're running on the same host, you could say that only that one has access to this S3 bucket, let's say. And you can be very granular in your access permissions with ECS.
Oh, so it's like a role for an EC2 host, except it's just attached to the container.
Exactly. Exactly.
That's, I mean, that's really cool. I think there's a couple of examples of that where we take the container and we sort of graduate it to being a first class citizen where we can attach networking to it and maybe even attach some storage to it. So I think that'll be a really cool thing to take a look at. We should look at that this week.
Yep. And I feel like you're getting me in the right direction here, but we will. That was a little tease there, Brent. I like it. That was that was good. But yeah, so we will. We'll talk about storage integration with EFS, Elastic File System, and so on. So let's let's quickly run through some of the components with ECS. So the first component of ECS is a cluster. So when you think of a cluster in ECS, don't let that startle you and think, oh my goodness, this is now I have so much to manage. It's just a logical grouping. It's like a logical namespace for where your containers are going to run. So if you want to run a service on a cluster, um, it's basically you're just using that to differentiate between different environments or different services. So those are some examples. You could have a production, staging, and test cluster, let's say, and all your services run on each of those clusters per environment. Or you could have service A has its own cluster, service B has its own cluster. So it really just depends on your use case and what makes sense, but it's really just a logical grouping, a namespace for you to group your containers. Um, and one cool thing to mention with clusters is they can be hybrid with EC2 as your backend. So EC2 is where you could run your containers, or it could be Fargate. So you could have a mix of EC2 backed containers running as well as Fargate containers running.
That's really cool.
So yeah. And everything is, so by the way, when you go through ECS Workshop, you'll see there's usually with these things, there's a link that will take you to the official AWS documentation where you can read more about it. So I'm going to kind of start moving away from saying containers, and now I'm going to start using the word tasks, which we're going to get to here. But a task definition is essentially a way to describe how you want your service to run, how you want your container or containers to run. You can have multiple containers run in one task. An example would be I have my API server running, which is a Flask, Python Flask service, but I want to also have a logging container that takes all the logs from my service and ships them somewhere else, ships them to Splunk, ships them to wherever. I can do that. Or maybe for metrics like Datadog's another use case where I want to ship metrics to an external metrics and monitoring service. And
Do you ever put anything in front of your Flask app, like an Nginx instance or anything like that?
absolutely, you could absolutely, or
Yeah.
like a service mesh, like app mesh, right? That's a
Uh,
great example where if we don't talk about service mesh in this workshop yet, we will at some point. We'll add that, but um, essentially that's a way to have a virtual network within your cluster or within your I would say your applications, all your services, um, to communicate with one another, monitor, have metrics and insight.
as far as totally, yeah. As far as the task definition goes, I think it's what you're pointing out multiple containers is an important like bit of knowledge that people you know come to eventually. It's good to know. It's good to have this realization. Your application shouldn't all go into one container if there are multiple processes. You should consider putting each process into its own container. And then think about what is my minimum deployable unit? So, like if you always deploy your Flask application, as you mentioned, but you always pair it with Nginx to handle static content, then that's a deployable unit. Those two things are always going to grow and contract at the same time, at the same rate. So you can put them both in the same task definition and have two containers. If, on the other hand, you're always deploying your Flask application, but it has to talk to a database or a different backend service, those things don't always deploy at the same time and they don't always scale at the same rate. So, those two things would be bad to put together in a task definition. So, that's kind of how you decide what goes in a task definition together versus what should be split out and have independent task definitions.
Great point. Great point. And but yeah, so this is just a little blueprint here of what a task definition would look like. But basically memory, CPU, kind of all the basics that you would need to make sure that you have enough resources for or you define your resource requirements for your containers, um, as well as any other type of advanced capabilities and port as well, of course. And so a task, so we have a task definition, which defines how we want our containers to run. And then we have a task, which is actually the instantiation of the task definition in your cluster. So when you can run a task in just ad hoc, there's just a run task API. If you just want to run something ad hoc, you can trigger it from a cron event through CloudWatch, or you can run it as a service. And we'll get into services in just a minute. But each task is going to deploy however many, when you run the task, it'll deploy however many you've set at that runtime, and then they're going to run for the duration that however long they last, unless it's a service that's managing and maintaining them. But what's in charge of making sure that these tasks run your containers is the task scheduler, which is ECS, right? So ECS is that orchestration. It's the maestro, who's the conductor, who is basically says, okay, I get a request. I need to run 10 instances of this Python Flask application, which is defined in a task definition. I need to figure out where to run them and get them running. And then we go into services. So a service is just simply a way to specify, how often, or I'm sorry, how many instantiations of a task you want to run, and then a service will run them indefinitely. The idea is, this would be just a front-end web service. I don't want this to go down, so I'm going to want at least 3 instantiations of my front-end web service running across 3 availability zones for high availability. So that's where the service comes into play, is it will actually orchestrate and ensure that your services are up and running with the exact count of replicas. So that's where the replica comes in, that they're running at that number as you expect. And then,
So let me get this straight. You have a task definition that describes how to run a container or set of containers. Then, as the orchestrator runs stuff, it's running tasks. So those are effectively just instantiations of the task definition, which is the containers.
Yep.
Then you might have a service that describes how many tasks there need to be to handle the amount of traffic. And it might also describe like how we should handle a deploy, how traffic should be routed to it, and that sort of thing. Does that sound about right?
Exactly.
Nice.
Exactly right.
So what more do you need? I mean, like that's basically everything. People have built, entire websites around that kind of structure. So that definitely gets us a long way for sure.
Yeah, and I totally agree. And the last type of service you can run is a daemon service, which essentially says, I want one instantiation of this task running on every single EC2 instance that is in my cluster. So another example would be a centralized logging task, that its job is to take all the logs from journal D logs and ship them to somewhere. So yeah, good point.
Wherever those things need to go.
Right, wherever they go, whoever reads them, I don't know.
I don't know if anyone actually reads that stuff.
Right, they don't. Maybe they do.
Someone does.
Yeah. So this brings us to Fargate. So Fargate runs on Fargate is can be used with ECS or EKS, but in the context of today, Fargate is built with ECS, and it allows you to run those tasks or those services, but without having to think about the underlying EC2 infrastructure that has to support those services. So that's fully managed. So the EC2, the virtual machine that's running your container, is completely abstracted from you as the user. You're just focused on getting a service running, making sure your container is defined as you expect, your task definition set, and you create your service. If you use Fargate, the EC2, don't worry about it. That's managed.
So it's interesting. I feel like this is a bit of a gear shift because, we've been talking about we talked about containers and running your app, and we're talking about like orchestration and how things get scheduled and the logic behind where stuff should be. In my head, I'm mapping all of this back to like running microservices on either, computers in a data center or EC2 instances. Like I can see how I would want to stuff some containers onto EC2 instances. But it sounds like what you're describing now is something that would replace the EC2 instance, right?
Correct. So Fargate, that's exactly it. So the difference is, if you had mentioned, if you're running in a really tight ship, and you're just a pro at operating orchestrators, with EC2 you can pack all your containers onto an instance. You can try to, ideally get your instance to run at the tightest capacity, 95% capacity. Um, but that's in an ideal world. Realistically, in the real world, I think most EC2 instances that are running the containers are, I don't even know if they're at 50% capacity. I'm just spitballing.
There's a Datadog survey that goes into that. I honestly can't remember the answer, but it's in like the mid 50% range. So like it's not very high. I can remember running containers, on clusters where we were seeing some pretty high capacity, but that's not with it without its own baggage. Like that brings a whole new set of problems along with it. So it sounds like, and in fact, one of the problems is how do you know when to scale? Because you'll have to figure out how to scale your containers, obviously. But then how do you then figure out how do I scale the underlying compute to have just enough to be able to host my containers? So
Yep.
it sounds like Fargate can sort of fix that problem for us by just taking away the underlying compute so that all we are running are the containers themselves. That's all we have to care about scaling.
Exactly, exactly, and that's a great point, right? There's two challenges. There's the operator challenge of how do I scale my EC2 infrastructure to meet the demand of the applications of the containers, the tasks, and then there's the challenge of the application is how do I scale that to meet the demand of the requests coming in. So you're right. There's this paradigm here of having to manage scaling of two separate environments, but they're closely related, right? They one relies on the other. It's very tightly coupled. So Fargate eliminates that. Go ahead. I see the movements. Please.
I didn't want to interrupt you. I was just like, in my head, it's like a sliding, like you always have to have something just slightly bigger than the thing right above it.
Yep.
So, or even worse, scaling. The go-to example is scaling up, but really the hardest thing is scaling down. So, like, imagine then, as you shrink down your container footprint, figuring out how do I shrink down my compute to go along with that? Because you might be left with like one container running on your stuff. So like, does that mean I have to keep that host running, or can I do something about that?
Yeah.
So there's just it's so nice to be able to just eliminate all of that logic and eliminate all of that worry and have just one less thing to have to manage, one less big thing to have to manage.
Yeah. I agree. And yeah, so that's Fargate.